completing the square in the past. You did it last year. You did it as freshmen. We're going to review it again. Okay? I'll start by saying this. Parabolas have two different ways of being written. There's a standard format that you're used to. That's just y equals ax squared plus bx plus c. That's a standard polynomial format. And then there's something called vertex format, which is y equals a times x minus h in parentheses squared plus k. That is critical because when we're in standard form, as we just saw the past couple days, we use negative b over 2a to find the vertex. Okay, the vertex comes from negative b over 2a, and then we plug it back in. In vertex form, here's the beauty of vertex form. The vertex is just your a, h, and your k. So if we have it in vertex format, it is so much easier just to look at it and say, that's hk, that's my vertex. Your a values do the same thing. Okay, if it's positive a, it opens up. If it's negative a, it opens down. So that does the same thing, but vertex form just flat out gives you the vertex pretty much, whereas standard form, we had to solve for it. So we're going to use our method of completing the square to change this standard format into vertex format, and here's how that's going to work. The first thing we need to do is get rid of this 18. So I'm going to subtract 18 from both sides. So we really just leave the first two pieces of the polynomial. We get rid of the constant. Now, if there's a coefficient on the x squared, we would have to divide it away. But it's just 1 here, so we do not need to divide everything by 1. And we need to complete the square on this to make it a perfect square trinomial. Something that I can take the square root of. Something that's a perfect square. And the way we do that is we take half of b. What's half of b in this case? Negative 4, right? Half of b is negative 4, and we square that. What happens when you square negative 4? 16. That creates the number that we need to add to make the right-hand side a perfect square trinomial. But we all know with an equation, you can't add something to the right-hand side unless you also add it to the left-hand side so they stay equal, right? So on the left-hand side, this becomes y minus 2. And on the right-hand side, we have just made this, by adding this to both sides, we have now made this factorable. It's a perfect square. It's got that perfect square trinomial special scenario. This is a perfect square. What's the square root of x squared? X. This is a perfect square. What's the square root of it? 4. And is the middle term double 4x? Yes. It's a negative, but it factors into x minus 4 squared. Factors into x minus 4 times x minus 4, which is x minus 4 squared. And then we add 2 to both sides. And this is now in vertex form. What is technically our a value? 1. So this parabola opens up. What is our vertex? 4, 2. H, there's a negative that's a part of the problem. The h value is actually 4, and then k is 2. So 4, 2. Yes? Vertex equals 4, 2. So if we were to graph this parabola, we would put its vertex at 4, 2. 1, 2, 3, 4, 2. And then it opens up. So just a quick sketch there. Any questions? Yes. Yes. Yep. H is always the opposite of what you, like we see -4, but it's actually 4, and then K is exactly as we see it. Okay? Now, compare this with the parent graph. Change your shift your mindset here. Think of transformations. If this is the parent graph and this is the new graph, how has this been shifted? This -4 happened within the function, so that's a shift in what direction? Right 4 units. And this is a shift that's happening after the parent function, after the squared, so this is shifted in what direction? So the original parent graph, which was originally the one we saw, got shifted right 4 up 2. Do we see that? So it plays both cards there. It's a transformation thing happening, which you can hopefully now see. And also we did it totally differently to get to the graph. We kind of completed the square and stole that HK. And so, by the way, back to what Maggie just said, which she pointed out something great. So our H value is always the opposite of the sign that we see? Yes, because that's that weird horizontal movement where everything is the opposite of what we think, right? Any questions on that? Okay, great. We already did part C, so we're good there. These are going to be slightly different because we have a coefficient, okay? So I'm still going to add the 2 over. You definitely always want to get rid of your constant. I lied before. I'm not going to divide everything by 3. I'm just going to factor a 3 out. If you ever have a coefficient on your x squared, you have to factor it out. So that's going to become x squared plus 4x. And then I'm going to leave a little space in here because I got to figure out what to add in there to complete the square. So again, just look at the trinomial. Look at the x squared plus 4x part. We have to take half of b, what's half of 4, 2, and square that number, which is 4. So I have to add a 4 in here to complete the square on that trinomial. Now here's the question of the hour. Pay attention here, look up at the board. I just added 4 in a set of parentheses that has a coefficient of 3. So what did I really add to the right-hand side? What did you say, Jordan? 12. I added 4 in a set of parentheses that's going to be multiplied by 3. I really added 12. So what do I have to add to the left-hand side to make sure all stays equal? 12. So if you have a coefficient, it becomes a little bit trickier. That coefficient, though, is critical. That's my A value. That's huge. And now my perfect square trinomial factors into what? What squared? Nate? X plus 2. How did you get that so fast? Share it with everybody else because you're ahead of the game. Okay, I'm gonna give it a different approach. It's always going to be x plus or minus some number, okay? All you need to think about is what was my half of b? Half of b was positive 2, that's always going to be that. Half of b in this previous one was negative 4, that's always going to be that. It's always going to be half of what your b was prior to squaring it, okay? Just for a quick shortcut. And then we just subtract our 14 over. And what is my vertex, Connor? What's my H value? What's in my H spot? What's that? But remember what Maggie said, it's always the opposite. So you see a positive 2, but you actually say negative 2, right? And the K is, what's HK? K is negative 14. Okay, any questions on that? We'll come back to B if we have time. Flip to the back. We're not going to have time. But we already did one like that. It's no different than the one we just did. This exercise 5 wants you to use the traditional formula. So like I said, if it's in standard form, you can use negative b over 2a, that process, to find the vertex if you want. Or you can transfer it to vertex form to find the vertex. You will get the same thing either way you do it. Does that make sense? I could do this 2 ways, but all I would be doing is showing you how negative b over 2a works and how completing the square and getting it into HK form works, and just to prove to you essentially that it's the same thing depending on which way you want to do it, okay? So we're going to actually skip that section. There's no need to keep doing more of the same. Number 4 is a great question. The function is strictly decreasing over which of the following intervals? Now, immediately Bo's on his calculator. Smart, right? Look at, you could graph this on your calculator and you could see when it's decreasing. So let's do that. Now, what is my vertex to help me set the window? 617, excellent. So my window, I can go from 0 to 10, that's fine, but my y-axis, I'm going to go from like negative 20 to 20. Actually, for my x, I'm going to go negative 10 to 10, just to keep it symmetrical. But my y, knowing that my vertex is at 17, I better make sure I get at least I show the point 617. Okay, so when is this decreasing? Kaylee M., what do you think? From when to when? What is it doing right here? If I'm tracing it, is this increasing or decreasing? Increasing. Tell me when it starts to decrease. Right there, at the vertex, which is at what x coordinate? 6. Who said that? Good, right? We said that 617 is our vertex. We can see that. That's the benefit of this format. So from 6 and beyond, it's decreasing. So what's our answer? 1. Andrew. Okay, calculator, we can learn from this. So he typed in this, negative 0.5, x minus 6 squared plus 17, and he hit graph. And I don't know what happened either. It might have just frozen. He doesn't really have a problem. Let's pretend we didn't have a calculator for a second. You guys just told me you know your vertex at 617, right? 617. What is our A value here? Negative. So that means it opens down. So couldn't you have just done that by hand and realized, oh, it's starting to decrease at 6 and beyond? Okay, just based on those little things of knowing what the A value tells you and so on is good stuff. X coordinate of the turning point of the parabola. Do you see how sometimes they call it a vertex, sometimes they're calling it a turning point? No big deal there. If it's already in this format, you tell me, do you prefer completing the square and changing the format, or do you prefer negative b over 2a? Do you? Really? You would. I guess it depends on the person. I would just say here that this is a little dangerous to complete the square because you see the 5 there? I'm eventually going to have to divide a 5 out from 27, right? So I would say negative b over 2a here. Negative 27 over 10 is negative 2.7. Okay. 16 is just a multiple choice version of completing the square. You guys want to do one more of these? Okay. So what's my first step, Cameron? If I want to take this and rewrite the format, my first step is to get rid of the Not yet. Not yet. What do I get rid of first, Micah? Look back at another example. What did I get rid of first? Either one of you. Yeah, get rid of the 55. I get rid of the constant first. So get rid of that 55. So it's y minus 55 equals 3x squared minus 24x. Then what, Micah? Look back at the front example if you need help. The one on the bottom left. Not yet. I got rid of the 2, so we're here. Then what did I do to get to this step? That 4 wasn't there. What did I do from here to here? I factored out the 3. You factor out the a next. So that's going to become 3 and then x squared minus 8x. Then I figure out what magic number I'm going to add in there to complete the square. Grace, what is it? What do I add right in here to complete the square? What's half of b squared? What's half of b here? Negative 4. Negative 4 squared is 16. I added 16 in a set of parentheses that was being multiplied by 3, so I really added 48 to the right. So I need to add 48 to the left. Who can use the shortcut? What does this factor into now, Aiden? Awesome. Squared, right? Always keep the square down there. And then add your 7 over. So look at the multiple choice ones. What's my answer? 4. Okay. 21 focus and directrix we're going to get to tomorrow. I don't believe there's any questions on your homework, but we will start by talking about that tomorrow. Here's what a focus and directrix are. You've never heard of them, right? A focus is a fixed point. A directrix is a fixed line. Okay? And a parabola is all of the points that are the same distance away from the focus as they are from the line. Fixed point focus, fixed line directrix, and we'll talk more about that. That's what all of tomorrow is about. So I'm just looking quickly at your homework. I don't believe I'm going to see anything on focus or directrix. I don't. So you don't have to worry about the fact that you did that. It's all tomorrow stuff. I'll take it. Are these the two I said I did?
Where do you get it about 48?
Okay, so you know how I added a 16 on the right-hand side? But I actually added 16 in a set of parentheses that was getting multiplied by 3. Right, so this, if I were to distribute, I really added 48. So I have to add 48. Good question, thank you.
It's fine if I just come down after school and sit here to do homework if I know.
Yeah, yeah, no problem. Oh, I didn't get it yet. Was it? Oh, God.